welcome to another episode in the Delta Conveyance Deep Dive video series, where we invite experts to talk about the science, technology, and engineering behind the proposed project. So far, we've explored a wide range of topics, including climate change, financing the project, tunnel construction, and Delta fisheries, among others. We return to the subject of fish again, this time with an in-depth look at the design and intakes of fish screens. Preventing the entrainment of fish, that is, preventing them from getting caught up in the diverted water, is a high priority, and many innovative technologies have been developed to meet the challenge. Here to tell us all about it are two of the project's leading experts on intakes and fish screens, Phil Ryan and Daryl Hayes. Phil is the engineering design manager and intakes lead for the Delta Conveyance Design and Construction Authority. He has over 35 years of experience with planning and design of major conveyance facilities, including large river and lake intakes throughout the United States. He has been a project manager for both the Freeport Regional Water Authority intake and the Natomas Mutual Water Company's Sankey diversion, both large intakes on the lower Sacramento River. Daryl is a supervising engineer in DWR's Delta Conveyance office. He has a long history working for both DWR and in private practice on the planning, design, and implementation of many fish facilities and river investigations in the Bay Delta, as well as in many parts of the United States. He's a past president of the American Fisheries Society's bioengineering section and enjoys collaboratively working on multidisciplinary projects like the Delta Conveyance Project. Welcome to you both.
Thanks, Katie.
Thank you.
So Daryl, let's start with the basics. Tell us about screen intakes. What are they designed to do?
Well, there's basically two functions of a water supply intake. So it's water supply as well as fish protection. So for fish protection, basically we draw water through the screen at a very low velocity. We have a barrier basically that keeps the fish out, and we accomplish this slow velocity by creating a large surface area in front of the pumps or the diversion facility. The intake screen mesh is sized basically conservatively, very fine slots to keep the fish out because at various times of the year, especially on the lower Sacramento River, there's a number of sensitive and endangered fish species that may be impacted by these diversions. Those fish can include salmon, Delta smelt, sturgeon fish, which are all currently listed as endangered or needing protection. So basically, we designed the facilities around those.
Okay, great. Thanks, Daryl. Phil, could you tell us a bit more about that? What determines the size of an intake? Can you give us an idea of the scale we're talking about for this particular project?
Sure. For the DCP intakes, we're proposing one or more intakes that are each going to be designed for a maximum diversion of between 1,500 and 3,000 CFS, diverting that flow from the river. Distributing that maximum diversion flow at each intake over a minimum screen surface gives you an area for the larger ones, the 3,000 CFS intakes, of about 15,000 square feet. All that screen area has to be below the water surface so that you can achieve the desired 0.2 feet per second approach velocity that Daryl just mentioned. You know, most of these facilities, when we design them, provide a slightly larger than necessary screen surface to be sure that a reasonably uniform velocity criteria can be achieved, even with some degree of screen blockage. There are a number of facility options that you can incorporate the necessary fish screen surface into that intake facility design, and we could talk more about that in a minute. But I thought it'd be good in the beginning here to actually take a look at some fish screen information and actually an example. And I think Daryl has something that he can show us about that.
Yeah, thanks, Phil. I have here, I don't know if you can see here, a sample of a fish screen, the material here. A lot of these materials use a slotted material made out of a corrosion resistant material like stainless steel. It's quite smooth, very strong, has a high open area here. And basically the slots are designed basically to physically exclude the fish. So I have in my hand here a little, about a 2-inch long fish. The screens themselves are actually designed for about 1 inch long fish. And the idea is that they can't go through the screen, basically physically can't go through. And then if they want to, they could swim away easily. And then we'd also want them to continue to pass on down by the screen. So there's a number of other screens out there, facilities, but that's kind of the commonly used one for on-river type systems. It's a well screen, basically, is commonly used for in wells. So it's got a large percentage of open area and it works quite well. They can make that both in flat plate, flat designs. I also have a cylinder over here, if you can see, a cylinder shape. They can wrap these into just about any shape that you want. The concept's the same, just divert water through this screening media.
So interesting. Thank you, Daryl. Okay, so Phil, what are some other major design challenges to keep the screen functional for both water supply and fish protection purposes?
So one of the key major design challenges is really focused on keeping the screens clean during operation. You saw the thin fish screen slots that Daryl showed you. They're only about the width of the edge of a quarter. And they do a great job, as Daryl mentioned, keeping the very small fish out. But debris like aquatic weeds and algae growth, they'll collect on the screens over time, partially block the water flow. And unlike fish, that debris doesn't swim away. So cleaning systems are required to loosen and remove that debris to keep the slots open. And then the fish agencies that regulate these intakes, for good reason, require an automatic cleaning system to keep that system functional. In the Sacramento River, there's many examples of various cleaning systems, but almost all larger facilities use some sort of a mechanically brushed cleaning system. Screens also can become biofouled, mainly by algae and aquatic plant growth, like I mentioned earlier, but sometimes organisms like invasive mussels attached to these fish screens, and they can really seriously hamper the operation. Like in this photo here, you can see that there's a good brush system cleaning is really capable of keeping these quagga mussels you see there from plugging the screens. So there are also other types of cleaning systems that are used on many intakes. There are air burst systems, but these require seasonal brushing because, you know, as the air bursts things off, things that are sort of attached to the screens, they stay attached, they blow out from the slots, and when the air goes away, they settle back down. So they require seasonal supplemental brushing to make sure the screens stay clean. And then there are some smaller diversions that use manual brushing where an operator would brush the screens practically every day or sometimes even more than that. But obviously those are not practical for a large diversion like those planned for the Delta Conveyance Project.
So another intake design challenge really comes to having the facility operate over considerable wide range of river conditions. So on the Sacramento River, during low flow periods, the screened intake must function in both, those conditions, low water, as well as during high river flood events. So we may want to take off some of the water during those. So this results in a facility that has to work over that range. So from the low elevation up to the flood elevation. So the range might be as much as 30 feet of difference in water surface there. So there are also, during those times, especially during low river times, there are operational rules. I think one of the other deep dive videos actually went into some of those operational criteria, but certainly during the critical times, these facilities wouldn't be operating, but they could. We have to design them such as that.
Okay, so I imagine that these different conditions and challenges determine the kind of intakes that are used. Can you walk us through what those are?
Yeah, absolutely. There's a number of examples along the Sacramento River system that highlight some of these different facilities. As you can see in some of the pictures here, we have an on-bank facility. That basically is a facility that basically diverts right off the edge of the river and diverts straight into a delivery type system. There are in-river systems, which is like the city of Sacramento. These are piers. Sometimes they get into deeper water. They can divert possibly from both sides of the facility and make the facility a little more compact. Those are practical for some areas. There's also off-channel or in-channel facilities, basically where you have a diversion off the river, and then you divert through a diversion facility on the side. A lot of these are called V screens because of the chevron shape, and those basically take the water out, but it also takes the debris and the fish with that portion of water, and you have to return the fish with those systems back there. So that's something that's a big site consideration. There's a number of different other facilities that other types for smaller diversions. When you're talking about a large diversion, maintenance becomes key. And so you need to look at these. We're looking at, we don't want to handle fish. We want to keep them on the river as possible. So the two main types that we're looking at for this project, basically, we looked at big plate screens. So a lot like the plate that I showed you, basically, where you have you create the surface area through the surface area that you need that Phil mentioned, and then you distribute the flows across the screen surface there, and then clean those with a brush occasionally. The other main type of facility considered out there is the cylindrical type, and as I have behind me here, basically it's a much more efficient type of a design because you get a lot of screen area in a smaller footprint.
Thank you, Daryl. So many options. So Phil, which of these options is currently planned for the Delta Conveyance project?
Okay, so let's consider the types that Daryl just mentioned relative to the Delta Conveyance project. The in-river system he mentioned, we considered that, but given the size of the intakes we're talking about, the invasive nature of the impacts, environmental impacts in the river to construct it and to convey the large conveyance pipes underneath the river to get it to shore were quite large, and that basically a large boat in the middle of the river is what the structure would amount to, does have the potential to raise flood levels higher than some of the other options. So that option, for those reasons, was not considered beyond that. The in-channel, the V-screen type system that Daryl mentioned, as he mentioned, it requires fish salvage at the end. The fish they cruise along the screens, and at the end of the V, they get captured in some bypass flow, and then they have to be returned to the river. That is somewhat disturbing to the fish. It's not quite as good as just being able to swim along the face of the screen with a very low velocity. And generally, the fish resource agencies don't like, they don't believe those are appropriate when other options are available to you, which they are in this case. So that leaves us with the on-bank type, which we've selected with the cylindrical screens. And that's in the photo you see on the screen here, shows a configuration of that on-bank configuration where we can build the structure along the bank, use sheet piles to train the flows from the bank right along the face of the river, and then return it back on the other side. So it has the least impact on the river. It allows smooth flow through there. And these types of structures are very easy to operate and maintain. And the choice of the cylindrical rotating screens over the vertical screens in this type of structure is really an advantage, since it's state-of-the-art equipment and it really has excellent fish protection. It results in the shortest structure and the the characteristics of those screens result in better cleaning of the screen face than the vertical ones. The vertical ones are essentially cleaned by a giant toothbrush that runs back and forth across the screen. And these rotating cylinders get much better cleaning from the brush. Plus, the screens are below the water level, so they don't make noise for any of the people who live around the structures. And they're very easy to keep in a highly effective operating condition. And that's also important because you get better fish protection if the screens are in the better functional condition.
Okay, great. Now, I know that a great amount of time and effort goes into determining the best location for the intakes. Can you tell us about how the locations of the intakes have been selected for this project?
Sure. There's a lot of drivers associated with selecting the intake location. They involve having enough depth to get the screens. You got to put that 15,000 square feet of screen under water, and that can be quite long and require quite a bit of depth. So you need that depth, and you also need suitable straight length so you can put the screen along the bank without it getting into the river where it might impact flood flows. You're also looking at the outside of moderate river bends or even along straight sections. You don't ever want to be in the inside of a bend because that's a goal is to avoid areas where sediment will shoal or sediment collects in those areas on the inside of bends. So you're looking at areas that you don't have to dredge in the river and that kind of thing. So that's why you want to be along a good straight section on the outside. And then, these intakes are more than just a river feature. They also have landside features. So you need suitable landside topography and other features along the land. And you also need suitable geology because they're large structures and they're built into the flood control levees along the river. So there are all sorts of geologic and geotechnical considerations. So considering all these things, the project looked at the Sacramento River between the confluence with the American River and just downstream at the confluence with Sutter Slough. So the American River comes in Sacramento, Sutter Slough's down around Portland. So the American River flows entering the river up in Sacramento gives us a quite large, the maximum amount of flow we can have in the river, particularly when it's not flooding. And that allows us to have the greatest sweeping velocities past the front of the structures so that fish can be swept past the structures as much as possible. Once you get down to Sutter Slough, the river starts to braid into channels and sloughs through the delta as it flows down towards the Golden Gate. So that set the area between the American River and Sutter Slough. So all of these things were considered, and all of this, the entire river reach in that whole place from Sacramento to Cortland was considered. There's only 5 suitable candidate sites that exist along the river in these areas that meet all these criteria. 2 of those sites were eliminated due to characteristics that were less favorable than the other 3 sites. And then the final 3 sites, the 2 of them were somewhat better. They were a little bit deeper, had better geology and less disruption on the land side. So, but there are 3 suitable candidate sites, and the EIR alternatives include anywhere from 1 to 3 intakes. And so combinations of those 3 sites were included in the evaluations and focusing on the 2 that are better for those that only have 2 or less.
Okay, great. So much more to consider than I would have ever thought. And of course, there's more to an intake than a fish screen. Phil, can you take us on a quick tour of the rest of the facility?
Sure. That is one of the things that I, in my job, frequently come across is people pretty much think that the intakes are just a river facility. But as you can see on the screen here, here's a rendering of a typical intake. And you can see in the front there is the river, and you see the large concrete structure along the front. And that's the actual structure where the fish screens are under the water in front. There's a log boom out front to help keep floating debris from impacting the screens. And then the river flow would go through the screens and flow into that concrete structure. And then as you can see that there's pipes that lead through underneath Highway 160, which in our case goes through the site and delivers that flow into the sedimentation basin. So then you see these large sedimentation basins and you might wonder what those are for. Well, if you consider that this flow is been flowing in the river at 3 or 4 feet per second, and the sediment is mixed up in the water, and then we divert at 0.2 feet per second, that sediment wants to settle out. So it will settle somewhere in our system. So the concept is to settle that sediment at the intakes in a location where it can be managed, rather than inside a 40-mile long tunnel that's 100 feet in the ground where it's very difficult to manage it.
So fascinating. Well, thank you both very much for taking the time today to give us this deep dive into intakes and fish screens. It's been another great opportunity to learn more about the project. Thanks so much.
Thanks,
Thank you.
Katie. It's been a pleasure.
Yeah, been a pleasure.
Thanks for watching this episode of Delta Conveyance Project Deep Dive. We hope you found it informative. There's a lot more information about the project in the other videos in this series, so check out the playlists and stay tuned for more videos. The next major milestone in the project will be the release of the draft environmental impact report, and we will be publishing a series of short videos to help you navigate and comment on that important document. Thanks again for watching.